Hello everyone. So in today's problem, we deal with the force couple system. Again, so first we read the question of what they are giving us and what they ask us to find. So first they said that we should replace the three forces by an equivalent force couple system at point A. So we look at the question here. We see the vertical beam subject to three forces in different location. So since we deal with the multiple forces, I will name it one by one. As for example, a 100 Newton, I'll call it F1. 160, we call it F2, and then lastly 240, we call it F3, for example. Now, the question asks us to replace those forces by equivalent force couple system. So this concept we have learned by the previous video of how we translate the force from one location to another and how the moment has been included to those replacement. Okay, first I'll show you the replacement of the force 100 here. I move the 100 Newton force F1 from up to point A here, 100 Newton. Then, since we know that if we move the force from one place to another, we should include the moment that would have been generated by the force at its previous location. So, in this case, 100 force is here, point A is here. So that means this force will generate the moment in this direction, which is a clockwise direction. Okay, so we must first assume the positive moment. I will give the counterclockwise as positive sign. So from now on, from this video forward, I will always assume the positive moment by counterclockwise direction. And also the force, I will assume at from left to right as positive force. Okay, so let's be clear by that. Now, moving to 100 Newton force that we move from here to here, the moment that generated, like I said, is in this direction. So we added that moment at point A here. So we call it M1. Okay. Now, once we remove the force, we should have removed the previous location of the force, okay, to avoid any further confusion we might have. So I will just simply remove it by this eraser here. Okay, now we are left by the question M1. So what might M1 be? So M1 was the moment generated by 100 Newton, and then the perpendicular distance is 600 millimeter. So we put it here, 100 Newton times 600 millimeter. Okay, now M1 is acting in opposite to counterclockwise direction, so that give us a minus sign here. Then M1 will equal to minus 60 Newton times meter. Okay, so we do the same thing with 160, which is F2. So F2 we move it here, 160 Newton. Then the moment that would have been generated by 160 Newton at point A is in this direction, which is again clockwise direction. So M2 here is equal to minus 160 Newton times 600 millimeter. So which should give us minus sign again, 96 Newton times meter. Okay, so I will remove the force of 160 shown here. Then I will add the moment at point A. Okay, that is in the, again, clockwise direction, M2. Okay, now lastly, F3. So I move F3 here to this line of action that was acting on point A here, 240 Newton. Okay, then in 240, this time the force here make counterclockwise direction. So I will give the moment here at point A, call it M3. Okay, so M3 is equal to positive, okay, 240 Newton times the perpendicular distance from point A, which is this direction, which is 600 millimeter plus another 600 millimeter, so we give us 1200 millimeter, and as a result we get M3 equal to 288 Newton times meter. Okay, then I will remove the force of F3 out of the figure to avoid any further confusion. Okay, so now we can see that there's a multiple force acting in the same line of action, and a multiple moment occur in this beam. So to reduce the to simplify the system, basically we have total moment of this figure equal to M1 plus M2 plus M3, then should give us total moment equal to minus 60 minus 96 plus 280, which should give us 132 Newton times meter. This positive sign is in counterclockwise direction, shown here. Then another term, which is the force term, we have to find total force, Ft. So total force is F1 plus F2 plus F3, which will give us plus 100, and then plus 240 minus 160. Then total force will become 180 Newton here. Okay, now let me simplify the multiple force and multiple moment here into one single force and one single moment. Okay, so I will erase all the forces, all the moment that I have, all the multiple moment that I have been written here, okay, into one single force. Okay, which is 180. You see that it's a positive sign, so that means the direction is from left to right. Okay, and the total moment is 132 in positive sign, which is give us counterclockwise direction here, M3 of 132 Newton meter, and Ft of 180. Okay, now we have solved the first question, and the second question is asking us to, if the force are replaced by a single resultant force, please determine the distance d below point A. Okay, so this basically means now the system we have simplified has one force, one moment, but they ask us to have only one single resultant force. So to do that, we first must see that if and only if we move the force from here to here. That means when we know that when we move the force from one place to another place, that will generate the moment all right, that will generate the moment that was previously occurred. So let's say if we have point here, point D here, the distance from point A to D is, let's say, the small d here. So if we move the force from point A to D, okay, we have to include the moment that would have been generated by 180 force about point D, rotation in D, rotating in about point D. Okay, so then we know that if we move it to point D, the moment generated should be in what direction? Should be in clockwise direction. Okay, so if I move the force from there to here, 180, here, that would generate the force in clockwise direction, which is this one. We call it MD. Okay, so now if we are able to calculate MD, then we can remove the force here at this point. Okay, so now we will left with one force, two moment in opposite direction. Okay, but our goal is to eliminate those moments, to have only one force to represent the whole system. So that means our MD, which is should be equal to minus MT. And you may ask, why is that? Why is supposed to be minus? Well, if the summation of the two moments in opposite direction and an equivalent of the moment in opposite direction, meaning that those moments will cancel out. So this moment and this moment will cancel out, and we will left only this single force, the resultant force that the question has been asking. Okay, so we derive MD equal to the moment that generated by this force and this distance. So 180 here time the perpendicular distance D here. So 180 times D. Okay, and since we know that the MD has a clockwise direction, so we put minus sign in front of it. Okay, and from the equation of MD equal to minus MT, so minus 180 times D equal to minus 132. Okay, we are trying to represent this equation here. Okay, then the minus sign cancel out. Okay, now the D is equal to 132 divided by 180, which will give us 0.73 meter. Okay, and that concludes the solution for this problem. Okay, so I hope you guys learn how to solve this problem by the equivalent force cover system, and then I hope you understand the approach I use in this way. So before closing this video, I will revise briefly on what I have done. So first, I move the force one by one from its original to the point A. Again, original to point A, original to point A. Then when I move the force, you will have to add the moment that would have been generated if the force was previously there. For example, this one, we have it here. So the distance from here to here is 600 millimeter. Then we should give us this direction of force, and so on. We do this with every force we have, and then we will left with three forces, three moments. Then I simplify the system by summation those forces and summation those moments to have total moment, total force. Then the question asks us to replace the system by the singular force, the single resultant force. Okay, so we move the force from here to here. That generate the moment that would have cancelled the original moment that was there. So now those two moments cancel out. The system is left with only one force right here. Okay. So in the whole figure, we were left with only one force. And the distance from that force to point A is, we already calculated to be 0.73 millimeter. Okay, then this is the end of the video. So thank you for watching. I hope you guys learned how to solve the problem. We'll see you guys in the next video.